Hello and welcome back to Chapter 4. Today we're going to look at Section 4.4, which deals with trig functions of any angle. Back in Section 4.3, when we were talking about the trig functions, we were only looking at trig functions that were restricted to acute angles of a right triangle. In this section, we're going to look at trig functions that will cover any angle, even obtuse angles. So, to look at trig functions of any angle, we're going to start out with an angle, theta, and it's going to be some angle in standard position where you have a point, which is called, xy, on the terminal side of theta, and we know that the radius of that circle that the angle would be forming is equal to the square root of x squared plus y squared equals 0. Now, just to point out, x squared plus y squared, and then taking the square root of that, that's really the distance formula, and because our angle is in standard position, we know that the center of that circle is at 0, 0. Therefore, that's where the x squared plus y squared comes from. So I've kind of done a little sketch over here to the side, and I do apologize, it is kind of rough, but we have some angle in standard position. We have a point on the terminal side that's labeled xy, and this distance right here is our radius. So based on that information, we know that sine theta is going to be our y value of the coordinate point divided by the radius. Cosine is going to be the x value divided by the radius. Tangent is going to equal y divided by x. And I do apologize, that was a mistake there. And then your reciprocal functions, cosecant is just going to be the reciprocal of sine, or r divided by y, when y is not equal to 0. Secant's the reciprocal of cosine, or radius divided by x, when x is not equal to 0. And cotangent is x divided by y, when y is not equal to 0. So let's go ahead and look at example 1. It says, let the point negative 2, 3 be a point on the terminal side of theta. Find sine, cosine, and tangent. So the first thing that I always do is I sketch to see what I'm looking at. So in this case, negative 2, 3, I know my x values are negative, and then my y values are positive over here in quadrant 2. So this is negative 2, 3. And so I'm looking at the angle that looks like this. So now if I want to find sine theta, I know that that was really y divided by r. I know my y value is 3, but I am going to have to go back and solve for my r value. And r is given by the square root of x squared, which is a negative 2 squared, plus y squared, or 3 squared. This gives me the square root of 4 plus 9, or I get the square root of 13. So I'm going to go ahead and plug that in up for my y value. And if I rationalize this, I'm going to multiply that by the square root of 13 divided by the square root of 13. So I end up with 3 square roots of 13 divided by 13. I'm going to have a similar setup for cosine. So cosine theta then equals x divided by r. My x value is a negative 2. R value is the square root of 13. When I rationalize this, I end up with a negative 2 square roots of 13 divided by 13. And my tangent of theta is going to equal y divided by x, or in other words, I have 3 divided by a negative 2, and there I'm done. Another thing we have to take into consideration when dealing with trig functions of any angle is the quadrant in which the point lies. The signs of the trig functions in the 4 quadrants can be determined by the definitions of the function. And what I mean by that is, let's take the example of cosine. Cosine represents an x value. Well, I know if I end up with a positive x value, I could either be in quadrant 1 or quadrant 4. So usually there's some other piece of information that's given to help me determine which quadrant I'm in. It will either tell me what quadrant I'm in, or it will give me the coordinate point, and I'll have to look at whether or not y is positive or negative, but there will always be some piece of information that's given to you as to which quadrant you're falling in, so that you know whether your sign is going to be positive or negative. So let's look at example 2 when it says that we're given the sine of theta is equal to 4/5 and our tangent value is less than 0. Therefore, we want to find what cosine and cosecant are. Again, I'm going to sketch the scenario that I'm looking at. When I look at this, I see that the sine of theta is equal to 4/5, which is really y divided by r. So this tells me that y equals a positive 4. So for a y value to be positive, I'm looking at either quadrants 1 or 2. However, I was given the fact that tangent was less than 0. Well, numbers that are less than 0 are negative numbers. So that tells me then if y is positive and tangent's negative, x has to be negative. So that right there then narrows it down and tells me that I'm looking at a point in quadrant 2. So if I go ahead and sketch this out, I'm looking at some point that's over here in quadrant 2, and I know that the y value is equal to 4, but I don't know what x is yet. And theta is going to look something like this. The next thing I'm going to have to do is I'm actually going to have to solve for my x value in order to find cosine, because cosine of theta is equal to x divided by r. Well, I know that r is 5 based on this right here, but I do have to go ahead and solve for x. So because I have 5 equals the square root of x squared plus my y value, which is 4 squared. So this gives me 5 equals the square root of x squared plus 16. I'm going to square both sides to give me 25 equals x squared plus 16. Now x squared is going to equal 9, which tells me that x equals 3. So cosine theta then equals 3/5. And if I want to go and find cosecant, I know that cosecant of theta is really equal to 1 divided by the sine of theta. And if sine theta was 4/5, then cosecant is 5 divided by 4. So my two solutions then would be 5/4 and 3/5. Our next problem, which is example 3, says to evaluate the cosecant and cotangent functions at 0, pi over 2, pi, and 3 pi over 2. Now, if you started to work on your unit circle memorization, you know that 0, pi over 2, pi, and 3 pi over 2 actually exist at the quadrant angles. So, if I look at my quadrant, I know that this here is 0, this is pi over 2, pi, and 3 pi over 2. And if I find the terminal side, or actually let's just go ahead and use our unit circle here. So if I have a unit circle, I can actually use I know what my r is. R is going to equal 1. At this point here, I'm going to have an x value of 1, a y value of 0. At pi over 2, I have an x value of 0, y value of 1. At pi, I have a negative 1, 0. And at 3 pi over 2, I have 0, negative 1. So, when I go to look at the cosecant function, cosecant of 0 is equal to, cosecant is really equal to r divided by y, which is 1 divided by y, which is 0, so this tells me that it's undefined. When I go to look at the cotangent of 0, cotangent is really equal to x divided by y, or 1 divided by 0, which is also undefined. Now if we look at pi over 2, cosecant of pi over 2 is going to equal 1, which is my r value, divided by my y value, which is 1. So I get a value of 1. Cotangent of pi over 2 is going to give me x divided by y, or in this case, 0 divided by 1, which is 0. When I go to look at cosecant of pi, cosecant is my r value, which is 1, divided by my y value, which is 0. So again, this is undefined. Cotangent of pi is equal to x, which is -1, divided by 0, which again is undefined. And now we're going to look at cosecant of 3 pi over 2, which is r, or 1, divided by a -1, which gives me a -1. And cotangent of 3 pi over 2 is going to give me x, which is 0, divided by y, which is a -1, or 0. So these are your cosecant, cotangent values at 0, pi over 2, pi, and 3 pi over 2, which are our quadrant angles. The next thing we're going to look at are what we call reference angles. The values of trig functions that are greater than 90 degrees can actually be solved by finding their corresponding acute angles. So the definition of a reference angle says, let theta be an angle in standard position, and its reference angle is given, or is the acute angle, and it's represented by theta prime. Theta prime means reference angle. So the reference angle is formed by the terminal side of theta and the horizontal axis. So just to kind of give you an idea, if we look at this axis here, and we go in and we're looking at theta right here, my reference angle, or theta prime, is going to be the difference from pi to that terminal side of the angle. So I would go pi minus theta would give me theta prime. Now if I look at something, let's see, I think I can change this. So now I'm going to look at an angle down here, and I'm going to be going all the way around here. And this over here is going to be theta prime. Well, if I want to find that theta prime, here I'm going to take 2 pi and subtract from 2 pi, I'm going to take away the theta angle, and that's going to give me my theta prime angle. So example 4 says to find the reference angle of theta prime. So for A, we have 213 degrees. So if I sketch this out, 213 degrees is a little bit more than 180, but not quite 270. So I'm looking at something over here in this quadrant. So my theta prime value is going to be this right here. So I'll say theta prime, and theta prime then is going to equal 213 degrees minus 180 degrees, which gives me 33 degrees. Theta equals 1.7. Remember, there's no unit on that, so I'm going to assume that that's 1.7 radians. 1.7 radians is just a little bit over pi over 2, because I know that if I go to pi over 2, or I'm sorry, if I go to pi, that's 3.14. If I go to pi divided by 2, that's like a little bit over 1.5. So 1.7 radians is actually going to occur up in this region. So this is theta, which means then this here is theta prime. So theta prime equals pi minus 1.7, which is approximately equal to 1.442 radians. Likewise, for part C, 144 degrees is in between 90 and 180. So I'm looking at a theta value of right here. If I want to find my theta prime, which is right here, then theta prime is equal to 180 minus 144, and that's going to give me 36 degrees. Now, this is a table that's in your box that's in your book, and it's kind of just a general suggestion. It says to find the value of a trig function of any angle theta, we want to determine the function value for the associated reference angle theta. Then, depending on which quadrant theta lies in, we're going to assign the appropriate sine value to the function. And by sine, I mean the positive or negative, and that all depends on which quadrant you are in. So if we look at example 5, we want to evaluate the sine of 5 pi over 3. Well, you can either graph 5 pi over 3 and see which quadrant you fall in, or you can use your reference angles and say that 5 pi over 3 is 1 pi over 3 less than 2 pi, so theta prime then is going to equal 2 pi minus 5 pi over 3, which is really 6 pi over 3 minus 5 pi over 3, which gives us pi over 3. So I know that when I take the sine of pi over 3, I end up with a square root of 3 over 2. However, because 5 pi over 3 is actually going to occur in this quadrant, so this is 5 pi over 3, I know that my y value, because that's what sine is a y value, is really negative. So I'm going to have to make this a negative square root of 3 over 2, which would mean that this is really a negative sine of pi over 3. Likewise, for the cosine of a negative 60 degrees, when I plot this out, a negative 60 degrees is actually going to occur in this region as well. Now on this one here, because this is a negative 60 degrees and I'm looking at the cosine value, I'm in the fourth quadrant. I know that cosine has the same sign, whether, and I'm talking positive or negative, as the first quadrant of 60 degrees. So this is really going to be equal to the same thing as the cosine of 60 degrees, which is 1/2. Now for part C, it says the tangent of 11 pi over 6. 11 pi over 6 is going to be 1 pi over 6 shy of 2 pi. So again, this is going to occur in this quadrant here. So this is 11 pi over 6. And when I take the tangent of that, it's really going to be tangent is equal to y divided by x. And my y values are negative in this quadrant. So I know that the tangent of 11 pi divided by 6 is going to give me a negative because x is positive, y is negative. I'm going to end up with a negative square root of 3 over 3. Now example 6 is going to be a little bit different. I'm going to have to use those trig identities that we learned in the last section and apply them to this section. So example 6 says, let theta be an angle in quadrant 3 such that the sine of theta is equal to a negative 5/13. We want to find the secant of theta. Well, secant is really 1 divided by the cosine of theta. So that's telling me that I need to find cosine based on a sine value first. So, using my trig identities, I was given an identity that said sine squared theta plus cosine squared theta equals 1. Well, in this case, I know that sine squared theta is really going to be a negative 5/13, and we're going to square that, plus my cosine squared theta, and that's going to give me 1. So I'm really going to have a value of cosine squared theta that's going to equal 1 minus 25 divided by 169. And that's going to give me 144 divided by 169. And if I square root both sides, I end up with 12/13. Well, I want to know when what secant theta equals in the third quadrant. So the last thing I'm going to do is I'm going to graph this, and in the third quadrant, I'm over here. I know that cosine values are negative. So when I go to evaluate the secant of theta in the third quadrant, I'm going to take the reciprocal of 13/12, and I know that it has to be a negative because I'm in the third quadrant. Tangent theta, I need to know both y and x, which I just solved for my x value. Based on my cosine, I know that this right here is really x, and based on my sine right here, I know that this is y. So for tan theta, all I have to do then is plug that in. And I end up with y, which was 5, divided by x, which was 12. Now if I wanted to use trig identities though, I could use the fact that tan theta is equal to sine theta divided by cosine theta, and I know that sine theta was equal to a negative 5/13, and I'm going to divide that by a negative 12/13, and if I multiply by the reciprocal, negative divided by a negative is a positive, and I'll end up then with 5/12. So there are a couple different ways that you could do this.